Okay, so for this lesson, we're going to talk about writing expressions, and we're going to be dealing with verbal models, which is an expression that describes a problem using words and labels, and using math symbols to relate those words. So one thing you need to know also is what a rate is, and a rate just happens to be a fraction that compares two quantities that are measured in different units. So then when we talk about unit rate, we're looking for a rate that's per one given unit. So it's kind of like when you go to the grocery store and you're going to buy a six-pack of water. So you look at the packages and maybe the Poland Springs is like $3.99 for 6 bottles. But if you look to the left of that, you'll see that one bottle maybe costs, I don't know, 59 cents. I have no idea. And then the same thing would happen if you compare that six-pack of water of Poland Springs to Stop and Shop six-pack of the same size. And you'll see maybe theirs is $2.50 for the six-pack because one of their bottles of water maybe only costs 45 cents. So the little number on the left is the unit rate, and then the number on the right is the price you pay for all of them. So we'll be talking about rates and unit rates. In terms of that, and just verbal models in general, there's some specific words that you should know, or even phrases for that matter, that mean these particular operations. So if we're talking about addition, you might see very often the word sum. You might see the phrase more than. You might see the word plus. Okay, just different words that you might see in problems that mean that you need to add whatever those numbers are. Subtraction, you might see in the problem the word minus. You might see the word difference. You might see the word less than. When it comes to multiplication, you might see the word product. You might see the word times. You might see the word of, actually. Okay, there's other ones, squared, cubed. I mean, there's lots of different words and phrases for each of these, but here are some of the ones that you tend to see most often. This last thing here is division, and so you might, in this case, see the word quotient. That's the answer when you divide. You might see the word divided by, and sometimes here you might see the word of. This one's kind of interesting. When they talk about multiplication, if somebody asks you for half of 10, you might think of being a problem like this, 1/2 times 10, which you know is just 5. But in this case, half of could also be division because if somebody says half of 10, you could set it up automatically like that, which is 5. So sometimes the word of goes either way. You got to figure it out in the context of the problem. So here are a couple of verbal phrases that we want to translate into expressions. This is the one that tends to be most tricky for people. 6 less than the quantity of 8 times a number. So when you see 6 less than means it has to come last. You need to know what 8 times the quantity of the number is before you can do 6 less than that. So it's 8x minus 6. This next one, 2 times the sum of 5 and a number. Whenever you see the sum of or the difference of, that has to go in parentheses. So what's happening here is you're going to multiply 2 times whatever the sum of 5 and that number is. The difference of 17 and the cube of a number n, the difference of 17 is just kind of translated exactly how you read it. 17 minus the cube of n. The quotient of 10 and the quantity of a number x minus 3, the quantity of, just like the sum of, needs to go in parentheses. So this would be the quotient, 10 divided by, the quantity of x minus 3. Some people might want to write this way. Another way to do this as well would be like a fraction bar. 10 divided by. Doesn't really matter how you write it, it's all the same. Alrighty, so now we're going to give you a word problem, see if you can kind of set this up into an expression. You and 3 friends are collecting canned food for a food drive. You each collect the same number of cans. Write an expression for the total number of cans collected. Well, you're looking for the number of cans collected, so maybe we'll do n equals number of cans. And it's you and 3 friends, which means there are 4 people. So the expression here would be, oops, sorry, I'm saying 4 people and I'm writing 3. So the expression here would be 4n. This next one is in example 5. Suppose that the total number of cans collected are distributed equally to 2 food banks. Write an expression that represents the number of cans each food bank receives. So in this case, what you're going to do is you're going to take the total number of cans collected and you're going to divide that by 2. Or if you want to simplify it, you can. This is actually how it's written, and this is simplified. I would like to see this one for sure, and then feel free to simplify it if you'd like. Now we'll talk about finding some unit rates. So we're talking about 3 gallons of milk cost $9.15. We want to know how much 1 gallon costs. So what we're looking to do in this case is going to be cost per gallon. So what happens is I'm going to be doing 9.15 divided by 3. I can come off on the side and do my long division. Bring my decimal point up. 3 is 9, 0, 1, 0. Carry down my 5, 15. So it's going to be $3.05 per gallon. Next one. A person drives 159 miles in 3 hours. We want to find out how many miles he can drive per hour. So I would do 159 miles per 3 hours, and then I could do the math somewhere on the side. This becomes 5, 15, 0, carry down the 9, and then I could end up with the 3. So this would be 53 miles per hour. And then my last one says that a recipe calls 20 cups of flour for 8 servings. So I want to know how many cups in a serving. So I would do cups per serving. And I know that 20 cups yields 8. So then I have to do some math again. Let me extend this a little bit into 20. So this goes 2 times 16, 4. Bring down the 0, bring up my decimal point, 2.5. So this is 2.5 cups or 2.5 cups per serving. Sort of abbreviating that, and that's okay. So you're going to be dealing with stuff like translating words into symbols, translating these symbols into words, and dealing with some unit rates, etc. Okay? So this should be good. Good luck on your homework.